All right, everyone. So today we're going to go over consecutive integers. It's very important to first understand the definition of consecutive, of integers, and how to imply it. So the word consecutive means in a row. So if I said consecutive days, that would be like Monday, Tuesday, Wednesday. So this shows us it's in a pattern in a row. So some examples of consecutive integers, where integers are our normal numbers we work with, so -1, -2, -3, 0, 1, 2, 3. The non-decimal, the non-fraction numbers. So if we wanted to do the ones in a row, we can say something like 1, 2, 3, 4. This is just an example, but there's a lot of numbers that are in a row that are consecutive integers. Consecutive even integers. So if we think about it, it's our even numbers in a row. So 2, 4, 6, 8. -2, -4, -6, -8, any even number in a row. And then our consecutive odd integers would be some like 1, 3, 5, and 7. Those are our odd numbers in a row. So this is the most important part to have written down. So I like to circle it, highlight it in my notes. If we're working with consecutive integers, we are working with n plus 1, n plus 2. So anytime you see plain consecutive integers, you know you're going to start with n. Your next one will be n plus 1. The next one will be n plus 2. The next one will be n plus 3. And our answer at the end that we're going to plug back in to see what our consecutive integers would be. Let's say we need 4 consecutive integers. The next would be n plus 3. So we're just going to keep going in a row by adding one more to each of these because it's in a row. The next thing we have to have memorized is the consecutive evens. So we start with 2n, 2n plus 2, 2n plus 4. So any number we plug in for n, we will get an even number, which is what we want. So this is also something we have to memorize. You start with 2n, then 2n plus 2, 2n plus 4. If we see the pattern, we're adding 2 every single time to our term here, our little constant term. So our next would be 2n plus 6 if we needed 4 of them. Then we have our consecutive odd integers. That's 2n plus 1, 2n plus 3, 2n plus 5. So we take our 2n, we add 1 to it. Then we add 3, add 5. So it's all the ones in a row, and you can test this out by plugging in n as 1. We would get 3. N as 1 for the next one, we would get 5. N as 1, we get 7. 3, 5, and 7 are consecutive odd integers. So let's see how this applies to problems. So I told you in this problem that an even integer starts off with 2n. I won't be putting that on a quiz or test, so make sure you have that memorized. So we want to find 3 consecutive even integers. Without even reading the rest, we see 3 consecutive even integers. So I'm going to write up here, we know that 3 consecutive even integers starts with 2n. The next is 2n plus 2. The next is 2n plus 4. So now it says those 3 have a sum of 54. We know sum is addition, so we do 2n plus 2n plus 2 plus 2n plus 4, and we set it equal to 54. All right, combine our like terms. 2n, 2n, 2n gives me 6n. 2 and 4 gives me 6 equals 54. Subtract 6 from both sides, we get 6n equals 48. So our n is 8. But I am not looking for n. I am looking for 2n. 2n plus 2, 2n plus 4. So I'm going to plug back in. So I get 2 times 8, which is 16, plus 2 is 18, plus 2 more is 20. So my answer would be 16, 18, and 20. So like I said in class, the most important part is to figure out what the equation is going to be. Solve the equation and then plug back in. 3 steps. Create, solve, plug in. Let's try another consecutive even. So now we're working with 2. So we know we have 2n and 2n plus 2. And once again, we're working with sum, so we're going to add them up. And we say it is, so is means equals negative 38. Combine our like terms, 2n and 2n is 4n, plus 2 is negative 38. Subtract, so 4n equals negative 40, and our n is negative 10. Once again, we must plug back in. So 2 times negative 10 is negative 20. 2 times negative 10 plus 2 is negative 18. Negative 20 plus 2 is negative 18. Make sure you You might want to put that in the calculator or something to make sure you're correct. And this would be my final answer. And to check to make sure I am correct, I can add up the 2, and it has to equal negative 38, which it does. Let's take a look at some consecutive odd integers. So if you look back at your notes, consecutive odds are 2n plus 1, 2n plus 3. So that's 2 of them, because we're only looking for 2, so that's all I'm going to care about. So now it says the sum, so we add them together, and we have 128. Combine our like terms. 2 and 2 is 4. 1 and 3 is 4. Equals 128. Subtract 4 from both sides. We get 4n equals 124. So our n equals 31. We're not done though. We have to plug it back in. So 2 times 31 is 62 plus 1 is 63. So then you add 2 more to that. That should be 65. And when you add those 2 together, we do get 128. So our answer is correct. So a way to know that, oh no, we're just going to stop here and we're going to say it's 31, 33. If I plug those 2 together, adding them together, I do not get 128. So I know I did something wrong. Oh, wait, I have to plug it back in, and that's how I get the correct answer. Now we have 3 consecutive integers that 3 times the smallest is 14 more than the largest. So this seems a little bit overwhelming, but let's break it up. We have 3 consecutive integers, just plain integers. So we know that's n plus 1, n plus 2. And I like to write this over here to remind me to plug them back in, remind me what I'm working with. So we have 3 times the smallest. The smallest is n, because if we're adding one more, it has to be the smallest, the n. So 3 times n is 14 more than the largest. N plus 2 is the largest, so 14 plus n plus 2. As you can see, we don't even use the second one, but it doesn't mean that we don't have to find out what it is. It just means that it's not important for solving the equation. So combine our like terms. 3n equals 16 plus n. Subtract n, we get 2n equals 16. So our n is 8. All right, plug it in over here. 8, 9, and 10. And if I want to check to make sure I'm right, I can say, okay, 3 times the smallest, so 3 times 8, has to equal 14 more than the largest. 10 is the largest, so we add 14, and we do get 24 equals 24, so I know I am correct. I'm going to skip that one because that one was just a little bit of a thinking problem. It's not going to be one you're going to see on the quiz or test, so I'm just going to skip that to get to the more important ones. So I want to find 3 consecutive integers such that 2 times the largest is 17 more than the smallest. So consecutive integers, once again, are n plus 1, n plus 2. So 2 times the largest, this one's the largest, and I know a lot of us are going to say, oh, 2n plus 2. No, because 2 times the largest quantity is n plus 2. So we have to put it in parentheses to make sure we're multiplying by both. If I just do 2n, you're forgetting about the plus 2. The plus 2 is still part of the quantity. Is 17 more than the smallest, which is n. So now we have to distribute. 2n plus 4 equals 17 plus n. Subtract n, I get n plus 4 equals 17. Subtract 4, I get n is 13. Plug it back in. We get 13, 14, and 15. And you can check to see if your answer's right. I skipped this one because I'm not going to go through into detail about 4 consecutive. I think that's a little much for now. We can take a look later, but I want to make sure we get the basics down before we go too crazy on this. So let's take a look at this. The sum of 3 consecutive even integers. All right, 3 consecutive even. I'll write it up here is 2n. 2n plus 2. 2n plus 4. And we said the sum, so let's add them together. Is 48. All right. Let's combine like terms. 2, 4, 6. 6n plus 6 equals 48. subtract 6, we get 6n equals 42. So our n is 7. And just looking at this, 7 is not an even integer. So I know, oh no, there's something else I have to do. Oh yes, I have to plug it back in. So 7 times 2 is 14, plus 2 is 16, plus 2 is 18. And if I add those up, I get 48. So I am good to go. So I could write 14, 16, 18, and put a nice circle or box around it. So hopefully this gave you some more clarity. You will help you on the problems, on the homework. You can take these and mimic the same thing on the homework. So hopefully this helped. You can take a look at the PowerPoint as well. And if you have any questions, you may email me. Have a great day, guys.